class, this is Mr. Roberts. We are definitely wrapping up Chapter 8, and we'll have a study team and an individual test soon. This is a preview, I guess, of what you might expect on the study team test that's coming up. This is based on the study team test I think I gave last year. So here's an example of a question that's kind of from this chapter. It says, find an equation in the form y equals ab to the x power. So we can see it's an exponential function that goes through two given points. One of them is 340 and the other point is 81280. And then I'm really nice. I say, hey, use the system of equations below to help you come up with A and B, right? So if you look at it, that first equation, you could probably solve for A first and then plug that into the second equation. And if you're real careful, you should be able to figure out both A and B using that method that we talked about in class. Let's see. Also new to this chapter, these are not new, right? Solve each of these equations. So there's a couple nice simple linear equations. One of them, I imagine, you probably use fraction busters, B to get rid of some fractions. The other one's just some distributive property collecting like terms. Let's see, find the equation lying through 2 points. I've been doing this for quite a while, so I'm giving you 2 points. Each one has an x, each one has a y, and find the equation of the line that goes through them. By the way, you could use that method that was discussed, right? If you look at it, if I write this twice, y equals mx plus b, y equals mx plus b, and I use the x and the y from this point and feed those into here, and I use the x and the y from the second point and feed those into there, I end up getting a system of equations where my slope and my y-intercept are the only variables, and I could solve that system and figure out the slope and y-intercept. That's one possible way you can attack that. Here's some problems that involve simplifying things with exponents and some negative exponents. When we write our answers, right, we can't leave any negative exponents in our final answer. And it's always a matter of kind of just looking at little parts. So if I look at this particular problem, if I'm focusing on this first, what I see here is 5x squared. That's the same thing as 25x to the 4th power. And if you're not quite sure why that is, you could write 2 of these. So you could write 5x squared times another 5x squared. And you can see 5 times 5 is the 25. And then x squared times x squared is x to the 4th. So that really is what that is, right? It's 25x to the 4th, still over a y, and then that's times, that's times the 3y cubed over 5. So more to be done there, right? There's definitely a y in the denominator once you do the multiplication. There's 3 factors of y in the numerator. Looks like there's also some floating factors of 5. So again, search those problems out, look for them and practice those. This one, our number one way of getting rid of negative exponents, and you could do this at the very start, right? If I wanted to, I could multiply this by, in parentheses, a times b to the 4th times c to the 2nd power, right? And I could put the exact same thing in the denominator, a times b to the 4th times c to the 2nd power. So if I multiply by that, I'm not changing the value, right? I'm just multiplying by essentially a giant, that's just the number 1. But what's nice about that is I end up with something to the negative 2 power and something to the positive 2 power, which is just something to the 1st power. I'm sorry, something to the 0 power, which equals 1. So this entire numerator part right here is just the number 1. And in my denominator, I've got, I've got exactly this down here, right? I've got this a times b to the 4th times c raised to the 2nd power. So over here I've got an arithmetic sequence and a geometric sequence, and those are given by a table. The first thing, part 4, says supply the missing values for each. So looking at those, can you figure out if it's arithmetic, what are the missing values? If it's geometric, what are the missing values? Remember, arithmetic sequences, we have repeated addition. We're adding the same thing as we move forward. Arithmetic sequences always can take on the form they're linear in nature, right? So you could fit an equation that would take that form on. The geometric ones, y equals a times b to the x power. Here we're multiplying by the same thing repeatedly. Question 5 says, hey, write an equation in the form y equals a b to the x that will generate the xy values in part 4. In question 4, part B, rather. So what equation is this situation it could be used as a generator for that sequence. The test starts with a couple, there's about 70% of this material is not from Chapter 8. It's review material. So in question 1, there's two systems of equation problems, right? Solve for x and y. You can see those there. Another thing that you're going to see on this test is a situation that leads to a system of equations, and to answer the question, you just have to solve the system. So this one, Cooper's selling pens and mechanical pencils. He sells the pens for $1.50 and mechanical pencils for $1.95. He sold 95 items and collected money. So one of them is the number of items sold, like pens P plus maybe M equals 95, and the other one is their dollar value. But this question will be real specific. It'll say write a let statement to show which variables you are using and what they represent. Be very clear about that. What are the variables? What do they represent? Then write a system of equations that you can use to find the number of pens and mechanical pencils sold, and then solve it. And then there's spaces here where you write each of your answers. And then the final problem that I want to preview for you is this one that involves some data. Shasta Dam has been kind of big in the news this year, but it's well on its way to being full. So the distance from the crest of Shasta Dam to the water measures how many feet the lake is from being full. So distance from the crest. If you were here, this right here, if the distance from the crest is 0, it's completely full. And down here, it's not full, right? It's got a long ways to get full. But what happens as the lake fills up, the miles of shoreline increases. So what that means is if you were going to walk all the way around the lake, it's 365 miles to walk all the way around it when it's completely full. And if it's 197 feet from the crest, right, the water level's low, it's only 147 miles to walk around it. So there's two variables here, distance from the crest and miles of shoreline. So basically I'm looking for you to model this, give the least squared regression line that shows the relationship between the two. So if this is x and this is y, what's an equation that would model this situation? And then also, what's the correlation coefficient, r, and for that least square regression line. So just give me an equation that models it, and then give me the correlation coefficient. I think there were a couple other problems. Oh, is the correlation coefficient r positive or negative? What does this tell you about the relationship between distance from the crest and miles of shoreline? And then it also asks you to use that model to make some predictions. Predict how many miles of shoreline Shasta Lake would have if it, I need to do some checking here. If it would have if the water line was 250 feet from the crest. So if you look at it, that's a number that was not on this data set. There's no 250. But if it was only 250 miles, or 50 feet from the crest, what would be the miles of shoreline there if this model held? And then it says plot the data on the graph at right and sketch your least square regression line. So you'll plot that data. All the points will get plotted, and you'll do a good job of showing me, where's the slope, or what's the y-intercept of your data, and then what's a line that fits it using your slope and y-intercept. And I think that's pretty much it. Those are most of the big ideas that are on the test. Again, the biggest questions that you're likely to see are right here. This is the newest material. Come up with the exponential curve that goes through those 2 points. And this is using one technique that we talked about. Oh, and I guess 11 is something. It's a review question, but you can see there's some triangles here, and for each of these, you need to give the congruence a congruent statement. So, like triangle BOX is congruent to which triangle, right? If these are congruent, what's the proper order to label the other triangle? And then what congruence condition is used to confirm that, or to establish that? There's only 4 of those congruence conditions. So anyways, that's about a 10-minute preview of things you'll see on the study team test and the individual test coming up this week for the study team test, and then early next week for the individual test.